So for number 8 out of homework from section 8.1, we are looking at a second grade population for how fast they can read. We have a mean of 91 words per minute and a standard deviation of 10 words per minute. So the first question, what is the probability a randomly selected student in the city will read more than 95 words per minute? So for the most part, every other question in this section is asked about a random sample mean. Well, this is not asking about a sample mean, this is asking about one student. The probability that one student, a single student, randomly selected, will read more than 95 words per minute. So what we want is actually from chapter 7, where we just need the mean, the standard deviation, and x. So we want to know whether a randomly selected student, what's the probability that they can read more than 95 words per minute? So I have x greater than 95. We need to change that to a z. I have the formula there. So I have 95 minus mu 91 divided by standard deviation 10. Leaves you with a z-score of 0.4. So since we want to know greater than 95 words per minute, we want to know greater than 0.4 on the z-curve. So I've drawn a z-curve with it shaded. Greater than 0.4 means we need positive infinity. So in our calculator, we do normal CDF. Our starting point is 0.4, and we use 999 for positive infinity, giving you an area of 0.3446. So that is the probability that a randomly selected student in the city will read more than 95 words per minute. We want to interpret this probability if 100 different students were chosen. Since we are out of 100, we look at the 100s place, and we have 34. It doesn't round up because the next digit is 4, so out of 100 students, we would expect 34 to read more than 95 words per minute. So the next problem switches from just a single student to a random sample of 13 students. So we're switching from just one single x to a mean. So what we need is what we used for the previous problems in this section. So first of all, our mean for the sample mean is going to stay the same. It's going to stay 91. Our standard deviation, though, is going to change. We have we need to divide the population standard deviation divided by the square root of n. So our standard deviation is 10, and we're taking a random sample of 13 students, so I'm taking the square root of 13 since n is 13. Okay, so I have a new standard deviation of 10 over the square root of 13. So again, I want to know what is the probability that these 13 students selected will have a reading rate of more than 95 words per minute. So it's the same scenario as before, only we're looking at 13 students instead of just one. So I need the probability that x bar this time, because I'm looking at the mean of 13 students, is greater than 95 instead of just x as it was for part A. So to find the z that correlates with this sample mean, I take 95 and I subtract the population mean 91. I divide by the standard deviation for the sample mean, 10 over the square root of 13. Okay, so I need to type that into the calculator. (95) minus 91 is 4. Then we're dividing. I'm going to open a parenthesis to start my denominator. 10 divided by the square root of 13. Close twice. So that leaves us with a z-score of 1.44222. So we're looking at z greater than 1.44222. So we need a normal CDF of 1.44222 to 999, because again, we're looking at something bigger than 95, so we're going to the positive infinity tail and the standard normal curve. So second, VARS, down to a normal CDF, 1.44222, comma, 999, gives you an area of 0.746. Sorry, I need another 0 before the 7 in between my decimal to round to 4 decimal places. So the probability is 0.0746. And we're ready for the next part of part B. If 100 independent samples of N equals 13 students are chosen, because we are greater than 95, we want to be more than 95, so I need choice C. And then the 100th place is the second decimal place, so 7 out of 100 students are expected to have a reading rate of more than 95 words per minute. So part C is the exact same process as part B, except we have N equals 26 instead of N equals 13. So you do the exact same process that we did for part B, only instead of N being 13, we have a simple random sample of 26 second grade students instead.